Hi, welcome back to DevOps presentation series. This is Satyadev. In the last presentation, I talked about three-tier architecture. Before that, I talked about monolithic architecture. We have seen 12-factor apps and how those 12-factor app could make the monolithic app in a better way, which can be treated as a three-tier architecture. And then we also discussed that we are going to discuss about microservice architecture. Now, before going to microservice architecture, there is one aspect of both monolithic and three-tier architecture that are there is nothing but the database part of it is outside the three-tier architecture, or the three layers or three tiers. If it is a monolithic, it's three layers. If it is a three-tier architecture, like three tiers, right? So, but in both cases, the database is outside. Now, when the database is outside, and when we want to make changes to the database or application, there are certain challenges that could be there. Now, as part of the challenges, there are certain things that needs to be taken care for in order to mitigate those challenges. So, what are those challenges? How do we make sure that our application is upgraded properly if you want to upgrade it, or make some bug fixes? So that's what we are going to discuss in this presentation. So in this presentation, I'm going to talk about how application can be migrated. This presentation actually aims at three-tier architecture, but is also applicable for monolithic, right? But whereas with microservices, it is not the case. I will talk about that in microservices when we go to the microservice architecture. So let's start the presentation. So application migration. For any software application, over a period of time, it may be necessary to change the application code as well as database schema, assuming that it's a database schema is RDBMS. Reasons could be changes in business needs or need for performance improvement, security, or legal mandates. Now, what it says is pretty much like we want to make changes to the code, want to make changes to the database. Do we really need to do? Yes, because what happens is once the application is running over a period of time, there could be more requirements from the customers, more features, or maybe some legal requirements, maybe some government mandated rules. Something would always change. You can't just run an application forever for years together. You need to keep upgrading it. Without upgrading the application, you can't. Means like you're not upgrading means it's like it's going to be soon out of commission, right? So any application that is useful to customers has to be upgraded, right? So, well, it's not just a code. If it uses a database like in a three-tier architecture or monolithic, the database also needs to be upgraded. So, as I said, the reasons could be business need or performance improvement. In order to improve the performance, maybe you want to index a table, then you may need to change the database, right? So, could be anything, right? So, that's what the first point talks about. In monolithic architecture or in the three-tier architecture, database is kept outside of the three core tiers, which is like presentation, application, data access. So in the production, it may be necessary to carefully perform database schema changes first to make sure that changing database schema should not break the existing code, which is yet to be upgraded. So what does it mean? Like, could be monolithic or could be three-tier architecture. Irrespective of that, let's say you want to make some changes to database application, changes to the code as well as the database. Let's take the scenario. Now, we have to make those changes carefully. Now, let's imagine a scenario. Let's say we first want to make changes to the, code piece of it. Let's assume that, let's do that. What happens is that the code is changed, but at the backside, the database is old, right? Let's say this code assume that the database has got an additional field. For example, in the old code, name is like only one column. Now you want to make it as two columns, first name and last name. Now you made changes in your code, say that you just get first name and last name, then you combine your code or do whatever business logic you want to do. Now, let's say you first put the code, upgraded the application, not the database first. Then you will have errors, right? So, and again, customers would be using the application once the application is up. So, it's always a general practice, a recommended practice, kind of must that first database should be upgraded, then the application. But in order to update the database, there should not be any access to the database, right? So first you have to shut down the application, then you have to shut down the database, then you have to upgrade the database. That's how you have to do. That's what the second point is. Once database schema is upgraded by using popular deployment strategy like blue green or canary, code can also be replaced with the new changes. This application code as well as the database schema upgrade process is known as application migration. So basically, whatever I said earlier is the same thing. The third point says, in order to upgrade an entire application which includes the database, you first need to upgrade the database, then you need the application. The step should be shut down the application, the code portion, whatever the front end, middle layer, or the data access layer. You shut down all three of them. Then you shut down the database, upgrade the database, then up the database. Then in the reverse order, you data access layer, business layer, and the front end layer. You upgrade those three servers also. If it is a 3-tier architecture, monolithic, no problem. Just upgrade everything because there is only one unit, right? So this process is called application migration. Now, I just talked about this migration at high level, but when it comes to database migration, there are certain challenges. So what are those challenges? We need to discuss, right? So in order to discuss those challenges, let's talk some prelude points, like initial beginning points, before seeing how to migrate the database. For database migration, following points should be kept in mind. As part of schema changes, following are the list of possible changes known as CRUD operations, CRUD operations, that could happen to a database schema. So I hope you all know what is database schema. Schema is nothing but the structure of the database, the tables, their structure, triggers, stored procedures, everything combined together, is called database schema. So you want to make some changes to database schema. There are 4 types of changes, not 4 different changes, 4 types of changes that are possible. They are called CRUD changes or CRUD operations. They are like create. When it comes to database schema, create means creating a database table. Let's focus on tables. It could be a trigger or it could be a stored procedure, but same thing is applicable. So create a new table to create a new table, add it to the schema. Rename, change the name of an existing table in the schema. Update, adding, dropping, renaming, modifying a column in a particular table in the schema. So again, this is applicable. I'm only talking in the perspective of tables and columns, but it could be applicable to any other components in a schema. Same logic applies. Drop, rename the existing table, remove the existing table from this schema. So that's what drop operations. So CRUD operations are possible. Now, for a particular upgrade release, all schema changes that are needed to be done are known as change set. So a change set includes one or more database schema changes listed above. Now, what is a change set? So for example, let's take an example like you have a table where you have a name column. Now you want to separate the name column into 3 fields: first name, middle name, last name. Now this is a column change, right? It's a table. In a particular table you want to make some changes. Also you have a table whose name is not properly named. You want to change the name of the table. Also you have an unnecessary column which you are not using at all. You just want to delete that column. Or you have a table, you have a column which it actually should not be as part of another table. This table should be a separate table. For example, cities and codes table. I don't know, just making this up. So all these things have to be done, right? So all these operations, you have to do it one by one, right? When you do it one by one as a list of changes, that's called nothing but the change set. So that means in this release, I am making this name change or column additions, deletion of a column, or separate creating a table. All these changes, when you make it into a one list of things, that's called a change set. Now, for each different release, the schema is given a version number. So yeah, it is very, very important to give a version number to the actual schema. So when you start it, normally it will be version 1. Maybe the next set of changes are done, version number 2, version number 3. Like that, you need to have a version number. So how to give version numbers, which we will discuss later in unit 3. But let's focus on giving say that for the sake of simplicity, let's say the versioning is done 1, 2, 3, 4, 5 like that. Now, a customer could be at any version of the schema. Let's say you have an application, to be 3-tier application or to be monolithic, doesn't matter. Now, you have a customer who actually bought our application, has set up this application in his environment. Now, he has been using this application for a long. Now, we at the software developers, we have been upgrading our database and stuff like that. Now, currently our database schema version is 10. Now customer says, okay, I want to upgrade my application. Give me your latest software. I will pay for it, for your latest software. So customers normally won't get all the software whenever they released. Based on their need only, they will take this, because for them, software is not the primary thing. Their customers are primary thing. Software is a tool for them. So they don't want to change the tool unless it is really necessary. So the customer could be at a very lower version compared to the latest version we have. For example, Microsoft releases very latest operating systems one by one, but still we are at a lower version of the operating system on our computer. We don't want to migrate unnecessarily. So because it's not going to be useful to us much, right? It's the same concept. So let's say customer could be at version 4 even though we are at version 10. So this is a possibility. I'm just trying to explain the possibilities of version things when it comes to customers. Now, how to do database migration? This year I'm going to talk about the various steps. Following steps need to be followed for handling database schema migration. First step, create a special metadata table in the database schema that stores the current schema version number. This is very, very important. So make sure that in order to have this migration thing in a proper manner, right, the first thing we need to have is a table, a separate table, a specific table, which contains only one column and only one row, which is nothing but the version number. Normally it will be like that only. But some people combine multiple things into one thing, like a master record table. There could be multiple columns which contain some other things, but let's stick to one table, one column, one row. So which is a version number column. Now, starting with version 1 of the schema till the latest version, capture all change set commands in a specific file called schema changes file in the schema version number order. Now let's say the current version of our database schema is 10. That means starting with version 1, like there is version 2, there are n number of changes. Version 3, n number of changes. Version 4, n number of changes. Like that you have until version 10 there are a number of changes. Now, each time what we should do is, we should collect all those changes, list them in the order in which they are done. That means at the bottom of the file, version 1. At the bottom on top of that, version 2 change set. We should clearly distinguish. This is version 1, this is version 2, version 3, version, like that. Top of the file is the latest version, which let's say 10, right? For example, right? So that means this file contains right from the beginning. That means schema creation till now. Whatever changes happens to, including the version 1 actually includes creating the schema tables. Create table, all these commands could be there. Doesn't matter. So, all these, over a period of time, what are the commands that are used? They should be in the chronological order. So, from bottom to top. The top one is the latest. So, store all those things in a file. Okay. And the third point is, there are database migration tools that can read schema changes file, upgrade the customer database schema accordingly. Format for the schema changes file is per the migration tool. Now, how do you migrate a customer? Let's say, as in taking the example of, that's what we are going to talk. For example, for a customer, if schema is at version 4 and if the latest version is at 10, then the migration tool would update the customer database schema by applying all change sets starting with schema version 5 till 10. Now, what we do is, so we don't give the database, right? We give only the schema changes file. So, and the migration tool. What customer does is, he puts the schema changes file and migration tool on his machine. He starts this migration tool. This migration tool opens this file and reads the commands version wise, version 1, version 2, version 3, version 4. Now it checks customer database. it has a version number. It also has the scheme database version number file, right? In the first step, right? So in the first step, we have created a metadata table. So in the version 1 itself, the metadata table is created. So it contains version number. Okay, it says 4 there. It understands that, okay, customer is at 4. Now, then it picks 5. See, from the change schema file, schema changes file, it picks change set 5. Apply the change set on the database. Then 6. Then 7. Like that, in a order, like bottom to top, bottom, keep applying all those changes. So, and then finally it becomes 10. That means the database schema is, the customer is now up to latest version 10. Right. So there is an example. For Java-based application, Liquibase is a migration tool that allows schema to be in XML or YAML or JSON or XML format. Basically, the format of the file could be, it doesn't need to be a text file. It could be any file like XML file or YAML file or JSON file. It could be anything to everything. So it depends. Like based on this tool that we are using, it could be anything. Like Liquibase uses any type of file, whereas certain files like Flyway uses separate XML file for each version of the schema, which is actually better because version number 1, there is one schema file. Version number 2, another schema for changes file. Version number 3, there is another, like that, if separate files. Now the advantage is you just read one file, update it, next file. It depends on the migration tool. It's not a complexity for the application, it's complexity for the migration. How it wants to handle it, fine. We have to store accordingly. The tool that we are using, we have to store accordingly. So after third step, now we can update the customer database. Now, this updates the database. Now, as I told you in the beginning, first you have to, in order to upgrade an entire application, including the database, first you have to shut down all the front end layer, middle, first front end tier, client tier, application tier, and then data access tier. Then like that you have to, and then database you have to shut down. Then you upgrade the database, just following these 3 steps, right? Use a migration tool, whatever version it is there, upgrade it. Now it's done. Now up the database, then data access, then application tier, then the client. Like that you have to up. Now rolling updates. Now what is the rolling updates? Generally, application migration requires, this we are talking about the code migration actually. Requires an application code server and the database servers will be down in the exact order. So yeah, I mean the front end, the front tier, the application tier and business tier and the database, they should be shared like I just now told, right? So in the order. Once the database migration is done, the database server gets started, as I told you. After that, application code also gets migrated and the application server gets started. So as just now as I told you. However, in some environments, for example, e-commerce environments, downtime for the application database is not desirable at all. In that case, special strategies needs to be followed for application migration, and those special strategies are called rolling upgrades or rolling migration. Now, simple way is to shut down the client layer, application layer, data access layer, database, upgrade client access layer, upgrade application layer, upgrade front end layer, then start in the reverse order, like database. I'll first shut down everything, then from database to the front end upgrade, then you start all of them in the same order. Now certain environments, like for example Amazon, you don't want to shut down Amazon in for half an hour, not even for 5 minutes, right? Because customers are affected and they lose a lot of money. So, but they want to upgrade as well. How to do that? So there is a special strategy that in order to do that. So that's called the rolling updates or rolling migration. For performing rolling migration, there should be at least 2 application servers. When I say application server, I mean all the 3 layers: client layer, application layer, and the data access layer. So all 3 of them should be load balanced. I think I have shown you in the 3-tier architecture that there are load balancers before all the 3 things, right? So that need to be which is called like first application server, second application like that. Present and load them on the load balance using a load balancer. So they have to be load balanced. Then this is how we have to do the rolling upgrade. The first step, when a load on the when load on the application server is low, then a rolling upgrade is done using the following. Now, since we don't want customers to be affected, but still we want to perform the database change, schema changes, as well as all the 3 tiers changes. But we don't want customers to be affected. In order to, that's called rolling upgrade, right? In order to do that, this is what we need to do. These are the steps we need to follow. First one, the very first step is to perform database migration. As I told you here, first database has to be migrated. As specified earlier, database migration needs 1 or more CRUD operations. Now again, do you want to have, maybe databases also can be load balanced. First you stop one database and channel all the traffic to the second database. Then you start. This is one thing you can do, or you can apply. But one important point is these migrations have to be done at a time where the load is very low. Maybe in the midnight, because it's Amazon.in. It's used only in India, right? So at the midnight you start doing this. Why midnight? Because there is obviously going to be less traffic. But there is no situation where there is no traffic at all. There is going to be some traffic, but it's going to be less. So they figure out based on the statistics, they figure out, okay, at this point from 3 a.m. to 5 a.m., whatever it is, right? It's going to be less traffic on the Amazon.in. So at that time they start this. First, they upgrade the database. Now, the very first step is to perform database migration. As specified earlier, database migration needs 1 or more CRUD operations. Following table specifies CRUD operations and corresponding database schema actions that need to be taken in order for the rolling upgrade to happen. See, for a normal upgrade, no, shut down everything, upgrade, then you start everything. Further, no, we don't need to follow this procedure. Simple, just upgrade the database, upgrade the application, then start everything in the order, reverse order. Whereas for rolling upgrades, that means even when the customers are using, you want to upgrade. This is the steps we have to follow. But CRUD operations we have to perform, but we don't just do the CRUD operations as is. We have to be very careful. Now, how do you create a table? Now, databases, you think that database is still running, right? So database is still running. You don't want to stop the database. You don't want to stop the database server. And in that context, you want to create a table. Can you do that? Yes, freely you can do that, because creating a new table is not going to affect the schema. It's just adding a new thing, right? So nobody is going to, since all the 3 code layers are using a old code, which is not upgraded. So, I mean, they just need old database. So you're adding another table which is used by nobody, which is fine, right? So that's the create. The second one is it is a safe operation, a new table being created without disturbing existing tables. That is the safest operation that can be done, which doesn't require any special action. So just you can create it, no issue there. Renaming. Well, this has an impact. If somebody because the application is still running, if somebody using the table, you can't just rename it like that, right? Don't rename in the first step. Create a new table with the desired name and copy the data from the existing table, then start dual writes. So this is what we need to do. Well, let's say you have a table name called A. Now you want to rename it as B, for example, right? Now don't just rename the table. You create a table B, copy data from A to B, then you have a stored procedure or a trigger, set up a new trigger that actually whenever you are writing data into A, you write into B also. That means even though you are duplicating data for some time, it's fine, because now B is on par with table A. So you have old table A and the new table B. That means it's like a renaming B, but still A is there. A has to be there because the code is old. So we are using the old code, right? For old code, A is there. Once you change the code, it will use the B. Right? That's how you rename the table. Update, adding a column. Well, if you want to add a column, you can just add a new column, right? It's fine. So, for example, you want to separate a name to first name, last name, middle name, and last name, 3 columns. Just add those 3 columns and write some script to take the existing names and split them and put it to those columns. Then again, you write a trigger to whenever a name comes in, split it and put it into the table. So that's how you can do that. That's what it says. Don't save. Now that's easy. The adding a column is easy. Dropping a column, uh, don't perform this step. Don't drop the column, just let it be there. um, it can be dropped when it comes to the next one. So renaming a column, same similar to the table, create a new column with the desired name and copy data from the existing column. Start dual writes, exactly like a table, right? So change the stored procedure, I use a trigger, do whatever you want to do. So but make sure that you have duplicate, you have a, I wouldn't call duplicate column, I would call a new column, and the data is duplicated into both the things with the things until some point of time, right? So I will tell you when that should be stopped and how in the next steps. Similarly, updating a column, simply renaming a column, but use slightly different name, which is desired set with the desired setting. So, well, you want to rename a column, don't rename it. You just create another column with the desired name and perform the dual writes. Like have a trigger whenever something is added to this column, add into this new column also. Dropping a table, don't do that. Even if you need to drop, don't do the dropping in the first step. We can drop, we have to drop actually, but in the latter steps, not in the first step. So these are the things. That means we are making sure that we are preparing the database schema for the newer changes, but we are not discarding the old changes, right? That's what we are done in the first step. Second step is whenever changes that are done in the first, they are done to make sure the database schema is backward compatible. So we are making sure that the database schema is backward compatible, that it works with the old code as well. That's what we are trying to do. This means same schema can be used for existing version of the application code that is certainly running in production, as well as with the newer version of the application code that is yet to be deployed. Change the load balancer. Now, so that means database schema changes are done as per the table actions that are specified. So it is backward compatible. The database schema is backward compatible. That means works for the old code as well as the new code which is not yet deployed. Right? So let's go to the next step. Change the load balancer configuration so that it points to the first application server and second application should be taken down. Even though database upgrade is already happened, since the upgrade is backward compatible, the first application server is currently running should not have any problems. As specified earlier, taking the second application server should not cause a lot of churn on the first application server, as migration is planned at a time when the load is very minimal. See, as I told you, it's a must to have multiple servers. When I say server, it could be data access server, it could be application server, it could be front-end server. All three the same logic. For all three same logic, first shut down the all three of them, we call them as servers. Okay, for the sake of understanding. But there are three different things. So let's shut down one server, which is maybe data access server. Then you have load balancer, right? For data access, you have two data access servers which are load balanced. For application, you have two application servers load balanced. For clients, you have two clients load balanced, right? So we talked about it. Shut down one of this, and make configuration that there is only one server that is currently running. It's okay, and they are all old code only. We haven't migrated the code yet. It's okay, and the database is changed, but it's backward compatible. So only one instance is there, fine. As there is not much load, one instance should be fine, right? So this is upgraded. Now, second application server, which is like data access layer or application layer or the client layer, which is down, which have shut down, upgrade with the new code. So now you add the new code, right? Now step 5. Once the second application server is upgraded with the new code, it needs to be started. Then start all the new servers as well. That means now load balancer is balancing two servers, one with the old code, one with the new code. right? The application server should not have any problems with the upgrade database schema, as it's going to change the second server is so both of them should not have problem with the schema, because the schema is backward compatible. That means it works for the new one, it works for the old one as well. But make sure that duplicate entries are not read into the database table. So that's very, very important. Now, the next step is change the load balancer configuration so that it points to the second application server, and the first application server should be taken down. Now, do the same operation for the first application server. So shut down the first application server, or maybe whatever it is, right? Whichever is not upgraded, then apply the same process. Once the first application server is completely done, it needs to be upgraded with the latest code. That needs to be brought online again. Now both servers are using the latest version of database schema changes. So both of them, you upgrade all the things. Code is upgraded, database is upgraded. Only challenge is that database is backward compatible. Like it has got unnecessary things still there. If more than 2 application servers are present, then above procedure needs to be followed for the rest of the servers. Like if the load balancer contains 3 application servers, fine, perform the same thing for third one also. Then once all overall updates for the latest schema changes are done, any redundancies done to schema as part of step 1 needs to be cleaned up using DB scripts. So once everything is done, make sure that you clean the database as per the DB scripts. So you write a DB script to make sure that because now both the code are same, they are not writing into the first name column anymore. They are writing into the name column anyway. You write in first name, middle name, and last name. So and you copied the entire data into the already split in the first step itself. So you can just delete that column easily. Now similarly, unnecessarily things you can delete. Renamed tables, delete those tables. Similarly, renamed columns. You can perform all these things properly. This completes the migration process. So thank you very much.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.